back, students. Let us start with the numerical of center of mass. In the last lecture I have told you how to calculate the coordinates of the center of mass and what do you mean by the center of mass. Let us recall, suppose this is the rigid body, and this rigid body, we assume that the whole mass of the body is concentrated at one point, and almost many times it lies at the center. This is the center of mass. And what was the formula for the center of mass? The position vector for the center of mass in the summation form was equal to the product of the mass and the distance of the particles from the center of mass, and I is equal to 1 to n, and here is mi. Suppose we are having 3 particles or 2 particle system, then RCM was m1 r1, I is 2. So first you will put m1 r1, 2 है तो 2 terms आप लेंगे, plus m2 r2 plus m2 r2, and I is m1 and m2. Summation is for the sum. And if you are going to calculate the x coordinate, then you will write x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. For y coordinate, m1 y1 plus m2 y2 divided by m1 plus m2. With this concept, let us solve this numerical. 3 masses 3 kg, 4 kg and 5 kg are located at the corners of a triangle of side 1 meter each. It means it is an equilateral triangle. Locate the center of mass. So first draw the triangle, equilateral triangle, and keep its one edge, one vertex at the origin. It means this coordinate is 0, 0. The side is 1 meter, so this is 1 and y coordinate is 0. And this in equilateral triangle there is a property, if you draw the normal from the vertex, it divides it into 2 parts. If this complete side is 1 meter, it means this is half meter and this is half meter. This side is 1 meter, this is 1 meter. Now you have to find the coordinate of this point. The x distance is, this point is at half meter from the x-axis, and from y-axis you don't know this value. Suppose this is O, A, B and C. You don't know BC. So first of all, find the value of BC by Pythagoras. So this is OC square plus BC square is equal to OB square. Find BC square. BC square is OB square minus OC square. OB is 1 square minus half square. This is 1 minus 1 by 4 or 3 by 4. So BC is root of 3 by 4, or you can write it as root 3 by 2. Now you have all the sides here, and you have to calculate, put the value of y coordinate here, root 3 by 2. Now there are 3 coordinates, 3 masses. M1 is 3 kg, M2 is 4 kg and M3 is 5 kg. You have to find the x and y coordinates. For x coordinate, I hope you have written all this. So write the formula here and we solve the question. The x coordinate will be x is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. X is equal to m1 is 3, x1 is 0 plus m2 is 4, x2 is 1 plus m3 is 5 and x3 is 1 by 2 divided by 3 plus 4 plus 5. This is equal to 0 plus 4, 4 plus 5 by 2 divided by 12. And take the LCM. This is 8 plus 5 by 2 into 12. This is 13 by 24. Check the calculation. 8 plus 5 by 2, 13 by 24 meter. For y coordinate, take it m1 y1 plus m2 y2 plus m3 y3, divide by m1 plus m2 plus m3, and you will have 3 into y1 is 0 plus 4 into y2 is 0 plus 5 into y3 is root of 3 by 2, and divide by 3 plus 4 plus 5. The value is 5 by 2 into root 3 and 12. So your answer is 5 root 3 by 24 meters. So the coordinates of the center, suppose center of mass is lying here. This is point P. So center of mass P, x, y, the values are 13 by 24 and 5 root 3 by 24 meters. I think this is all clear to you. Note down every step and understand all the points. Main point is you have to find this height for the y coordinate. Okay, note all the points. The next question is, find the center of mass of a uniform L-shaped lamina. This is given to you. The mass of lamina is 3 kilogram. We assume that the shape of this lamina is of uniform mass, you can say, or uniform area. This is the L-shaped lamina. I have divided it into 3 equal parts. The mass is 3 kilogram, so I take it 1 kilogram each. And the uniform figure is this. It means this side is 1 meter. This side I assume is 1 meter. If I half it from both the sides, this is half, this is half. This value is half and next half here. So mark the coordinates of the point O, B, D, E, F and G. Or all the coordinates you should know. This is the origin 0, 0. Here the x-axis is 1 and y-axis is 0. And at this point, the value on x-axis is 1, this distance, and on y-axis is half. Here it is at a distance of half from the x-axis and half from the y-axis. So its coordinates are half and half. For point F, from the x-axis it is at a distance of half, and from the y-axis it is at distance 1. And at G point, from the x-axis, the value of x-axis on y-axis is 0 and the value of y-axis is 1. The masses are M1 is 1 kilogram, M2 is again 1 kilogram, M3 is 1 kilogram. Okay, and C1, C2, C3 are the center of masses, and you have to find the center of mass of the whole body. So for C1, what are the coordinates? Let the coordinate are x1, y1. For C2, x2, y2. For C3, x3, y3. So you have to find now the coordinates of x and y. X, y. C1, C2, C3. Okay. For C1, the coordinates are, mark this point. If you have taken the complete value as 1, so this is half of the half value. It means the C1 is 1 by 4 from here and 1 by 4 from here. If this complete value is 1. You can also take it 2. 1 is this and 1 is this. You can take like this. And because the dimension is not given for the length, you can take it as 2 meter or you can take it as 1 meter. I mentioned here, let OB is equal to 1 meter and OG is also 1 meter total value. And what about C2? The Y value is half and X value is half up to here, half plus 1 by 4. Half plus 1 by 4. This is 2 plus 1, 3 by 4. So the x value is here, the x value is 3 by 4 and y is 1 by 2. What about C3? The x coordinate is at 1 by 4 because half of this value 1 by 4 and y coordinate is, this is half plus 1 by 4. So the same value 3 by 4. Now you are having the coordinates of x1, y1, x2, y2, x3, y3. Find the center of mass. The center of mass may lie anywhere here in the body. So you put the formula for the x and y coordinates and calculate this. For x coordinate, you can have m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. This is 1 into x1 is 1 by 4 plus 1 into 3 by 4 plus 1 into 1 by 4 and divide by 1 plus 1 plus 1. This is 1 by 4 plus 3 by 4 plus 1 by 4. It means 5 by 4 multiplied by 3. So answer is 5 by 12. And for y coordinate, similarly m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. m1 is 1 into y1 is 1 by 4 plus 1 into 1 by 2 plus 1 into 3 by 4. You can solve it by taking the LCM 1 plus 1 plus 1. So y is equal to, this may be 2 by 4, 3 by 4 and 6 by 4. The value is 6 by 4. After taking LCM, you have 6 by 4 and divide by 3. This is 2. 1 by 2. So the center of mass C, x coordinate and y coordinates are 5 by 12 and 1 by 2. This is almost 0.441 and this is at 0.5. So you can have almost here, you can have the center of mass. You can note all the values, all the parameters. If you take it 2, then these coordinates will change. If this is 2, this becomes half and this value becomes, this is 1 and this becomes half. So the value will be half of the given parameters. Check it out. This is for y. First is, yes, 1 by 4. Y coordinate is 1 by 4. For second, y coordinate is again 1 by 4. It should be. Yes, this is 1 by 4. This is not half. I was feeling some error in the question. The y coordinate is 1 by 4. Here the value is 1 by 4. And this is 1 by 4, 1 by 4, 2 by 4, 5 by 4. This value is 5 by 4. 5 by 4 into 3. This is 5 by 12. 5 by 12. The answer is 0.41. How I got the idea that some error is there? Because for the regular shaped body, the both coordinates should almost be same. That's why I got an idea there should be some error. This is half and half of this value is 1 by 4. So y coordinate was wrong here. You can correct it. Note down all these steps. This is one more numerical. Find the center of mass of the given shape. If m1 is 5 kg, m2 is 1 kg and m3 is 1.5 kg. Sides are given. This is 4 cm, 5 cm and this is 3 cm. First point is to find the coordinates and then you have to put in the formula A. This is the origin, you can say. So both the values are 0, 0. The coordinates of B, the x-axis is at 4 cm and the y-axis here is 0. These are the coordinates of B. The coordinates of C. Here on the y-axis x value is 0 and this is 3 centimeter. So y coordinate is 3. So these are the value of x1, y1, x2, y2, x3, y3. And masses are 0.5 m1, 4 m2, 1 kg and m3 is 1.5 kg. You will put in the formula x is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 and you will get the answer 1.33 centimeter for x. Similarly for y you will get 1.5 centimeter. And solve this question by yourself. In this way you can solve the numericals of center of mass. In the next video, in the next lecture, we are going to discuss about the motion of the center of mass, the velocity of center of mass, how its linear momentum changes, how its velocity remains constant or variable. So note these 3 questions and solve it by yourself. Okay.